I just want to briefly introduce our ESR project, which is entitled Microalgal Population Dynamics Related to Changes of Environmental Conditions. So our early stage researcher is in-house. It's Job Ihatiarene. I hope I pronounce it in the right way. I have to learn. So I'm currently postdoctoral researcher at the Institute of Natural Materials Technology, and he will be supervised by our chair, which is Professor Walter, which has a strong background in synthetic biotechnology, metabolomic studies, and so on. And we will try to merge our competences in his field and in my experiences in algae biotechnology to supervise him here in a good way. I just wanted to show here this very multidimensional systems which we have in our field of research, and we understand our role here for this early stage researcher more in this area of biology. Due to the very heterogeneous conditions, we photosynthetic active radiation fields, energy fields, and so on in the reactors have been already mentioned, and of course the usage of CO2 as a gaseous substrate for this process definitely has impact on the population dynamics, and this can be on different steps or on different phases. This starts with the cell cycle, the cellular product contents, and the kinetics, as well the photosynthetic kinetics and the growth kinetics. And I brought here just an example of one of our working horses, which is Chlorella zofingiensis, a natural producer of a bright variety of carotenoids, for example, astaxanthin, zeaxanthin, kantaxanthin. And it's really interesting biological system because it can perform this carotenoid synthesis under a wide range of conditions, photoautotrophically, mixotrophically, and heterotrophically. And but what becomes obvious, and this is on the left side here, there is a huge diversity in physiological stage and the stages. And this is under, let's say, physiological non-limiting conditions, which is normally in a two-stage concept. And there we have here, for example, in the cell cycle, a great variety of different metabolic stages. Something which, in our opinion, could be optimized because, of course, these subpopulations form different in our process, and the overall goal should be that all cells perform in the same way. And this is more or less the same view here on a nitrogen depleted conditions. There is a great heterogeneity, and having this in mind, and having more background information, what are the metabolic activities which are taking place here, can help to improve the efficiency in an overall way. So our research task here is, first of all, to do really basic research on what are the environmental factors, nutrients, CO2, photosynthetic active radiation, how do they impact first the cell cycle, the multiple fission of the cells, also to provide something like a protocol for later metabolic studies. Then we have to develop a routine where we can create synchronous cultures so that really every cell in our culture is in the same physiological state. Then we can analyze from that point as well the multiple fission, but also quantitative metabolomics, so we can see in what stages are what metabolic routes active, and can we improve our process by using this information. And of course, we also want to develop for these issues population models, which can be integrated then in more global models, for example, and then there I hope for a nice interaction also in the network. We will use different equipments also in small scale, but also of course want to transfer this information and have a look on it, how it is on a larger scale. And in the field of analytics, we will work a lot in the single cell analysis, which means flow cytometry, imaging flow cytometry. And if we go to the metabolic action, then we are using LCMS, metabolomics, and so on. So I'm really looking forward to the project, and this was ESR7.